Hello and welcome back to this channel. Dear students, this lecture is for revision of DSP, Digital Signal Processing. I will be explaining few important topics related to this subject DSP. What we will cover in this session, I will explain you about DFT, then FFT, then IR filters, that is infinite impulse response filters, FR filters, then different window techniques used in FR filters and so on. So without wasting the time, let us start the session. First part is DFT and FFT. DFT stands for discrete Fourier transformation. From the exam point of view, you should know the defining equation of DFT. Before that, notation is if x of n is any discrete sequence, then its DFT is denoted by bidirectional arrow and mark capital X of k. K is the notation used in DFT. The mathematical formula to calculate DFT is x of k is summation n is equals to 0 to n minus 1 x of n e raised to minus j 2 pi k n upon capital N. This is the mathematical equation by which you can calculate the DFT. Now, there is one important term related to DFT that is known as the twiddle factor. This twiddle factor is a mathematical term which is denoted by Wn and which is given by e raised to minus j 2 pi by capital N. So if you want to write equation of DFT in terms of twiddle factor, then in place of this term e raised to minus j 2 pi by n, I can put the notation Wn. So simply formula becomes x of n into Wn raised to kn. This is the defining equation of DFT in terms of twiddle factor. Now, if you want to solve numericals using DFT, this is the mathematical equation. If you try to solve the numericals using mathematical equation, it will be little bit lengthy. So the simplest technique to solve the numericals is make use of the matrix method. How to solve the numericals using matrix method? Suppose the question is, it is asked to calculate DFT of some sequence, let us say 1, 2, 3, that's it. Now, one important concept, let me explain you. DFT should be like 2-point DFT, 4-point DFT, 8-point DFT, 16-point DFT and so on. What is this 2, 4, 8, 16? The defining equation of DFT in terms of twiddle factor or in terms of matrix is matrix Wn into x of n. This matrix Wn is the matrix of twiddle factor. Processor works with binary, so we have the value of this Wn such as W2, W4, W8, W16 and so on. So whatever given sequence it is, this contains 3 samples. I need to make its length 4 or 8 or 16 and so on. It will be easy in this case to make the length 4. So simply add 1 0 just to adjust the length of this sequence. This effect of adding zeros in order to adjust the length of sequence, this concept is known as zero padding. So addition of zeros to adjust the length of any sequence is known as zero padding. Now how to do the calculations? So this is the formula to calculate the DFT. This is the matrix of W4. You need to memorize this matrix. Derivation is not at all required while solving the numericals, but you need to remember this matrix. It's very simple. See, these values, I mean first row and first column is 1 1 1. Then about second row, it is this value is 1, that is fixed, minus j minus 1 j. Look at the last row. Just change the sign of j. This is minus j, it becomes plus j. Minus 1 remains same. We are just changing sign of j. So it is plus j, it becomes minus j. And third row is 1 minus 1, then 1 minus 1. This is the third row. Now it's simple to memorize this matrix. How to do the calculations further? This is the given sequence x of n. Write this sequence as a column matrix. So I will be writing it like this: 1, 2, 3, 0. Simply take the matrix multiplication. Whatever answer you will be getting, denote it by x of k this will be the DFT of given sequence x of n. This is the way how you can calculate the DFT of any sequence. What about IDFT? Suppose you want to calculate IDFT of some sequence. Let us take one example. Before that, the formula to calculate IDFT is denoted by x of n, small n, is equals to 1 by n matrix Wn asterisk. Asterisk denotes complex conjugate into DFT x of k. So, if you will be asked to calculate IDFT, then given sequence will be sequence of x of k. That means the DFT sequence will be given. Let us say the given DFT sequence is 6 minus 2 plus 2j minus 2 minus 2 minus 2j. Just as an example, I have randomly selected one sequence. This is the given sequence for DFT. Now, you have to make use of this formula to calculate inverse DFT. I am talking about inverse DFT. So, the formula becomes x of n is equals to 1 by n. N means the number of samples in the given sequence. There are 4 samples in the given sequence. So, it becomes 1 by 4 into Wn asterisk. This was the previous matrix for W4 which I had written. Now, how to generate matrix of complex conjugate, that is Wn star. Very simple trick. Just change the sign of j term. Keep 1 and minus 1. Wherever 1 is there, wherever minus 1 is there, keep it as it is. Simply change the sign of j term. For example, this is minus j, make it plus j. This is plus j, make it minus j. This is plus j, make it minus j. This is minus j, make it plus j. This is plus j, so I am skipping the sign. So this is the matrix. This is the matrix for Wn asterisk. That is complex conjugate. Then write the given sequence as a column matrix. This is 6 minus 2 plus 2j minus 2 minus 2 minus 2j. Again, same procedure. Take the matrix multiplication. Whatever answer you are getting, divide each value by 4, because outside this multiplication of matrices, the term is 1 by 4. So after performing multiplication, divide each term by 4. That answer will be the answer of x of n. Presently, in this case, you will get the answer 1, 0, 1, 2, 3. This is the way how you can calculate the inverse DFT. Suppose the question is like this. Some sequence is given. For example, x of n is given like this. 1, minus 1, 2, 1. Any sequence. And if it is asked to calculate the DFT and check the validity of answer, what does this mean? You will be first calculating the DFT using this formula. Just now I explained you. You will get some answer. Take it as x of k and then calculate inverse DFT using this formula. You should get the original sequence. This is the way how you can check the validity of your answer. So this is about the calculation of DFT and calculation of inverse DFT. As I mentioned, you just have to simply memorize one matrix which is used to calculate the DFT. Now, next important part related to this unit is circular convolution. There are different methods used to calculate the circular convolution of two sequences. Suppose given sequences are x of n and h of n. I'm explaining the statement. What is the statement of circular convolution? If two sequences are given x of n and h of n, circular convolution between them is denoted like this. Draw one small circle, write n inside it. It is read as n point circular convolution of x of n and h of n. If you take DFT, in DFT it becomes multiplication. That means DFT of x of n is x of k. This notation of circular convolution becomes multiplication sign. So into capital H of k, which is DFT of h of n. The mathematical equation, DFT of result, DFT of circular convolution is denoted by y of m. The mathematical formula to calculate y of n is summation n is equals to 0 to n minus 1 x of n h of double bracket m minus n. This is the mathematical equation to calculate the circular convolution of two sequences. Now first is a graphical method. If in the exam it is asked to calculate the circular convolution using graphical method, then and then only you need to follow this method. Otherwise, there is one simple method which is a matrix method. I will also explain that method. I will consider two sequences. Suppose given sequences are x of n is equals to 1, 2, 3, 4 and h of n is equals to 2, 1, 2, 1. It is asked to calculate the circular convolution of these two sequences. How to do it? I am talking about first method, that is a graphical method. So first draw one circle for x of n like this. There are 4 samples in the given sequence x of n, so divide circle into 2 parts. By default, as a convention, this is taken as a starting point. For the circle x of n, mark samples in anti-clockwise direction. Anti-clockwise direction means like this. This is the starting point, so it is 1, 2, 3, 4. In all steps, we'll be following different steps. In all steps, this circle of x of n remains as it is. What I did, I have divided circle into 4 parts. This is taken as a starting point, and I have written the values in anti-clockwise direction. Outside this, draw the circle for h of n. So this is the circle for h of n. Again, take this as a starting point, as a convention. But for h of n, mark samples in clockwise direction. So for x of n, I have marked samples in anti-clockwise direction. For h of n, mark samples in clockwise direction. Take this as a starting point. So samples will be 2, 1, 2, 1. Then remaining part is pretty simple. Take multiplication of nearby elements. That means this is 1 into 2. So answer is 2. Then 4 into 1. It is 4. 3 into 2. It is 6. 2 into 1. It is 2. And last part is add all these values which are obtained by taking multiplication. So it is 2 plus 4, 6 plus 6, 12 plus 2. It is 14. So first answer, which I will denote it as y of 0, is equals to 14. Now, what is the next step? As I mentioned right now, every time keep inner circle as it is. So I am keeping inner circle as it is. Rotate, after that, every time rotate outer circle in anti-clockwise direction by 1 position. Don't get confused. Initially, we have drawn a circle for x of n in anti-clockwise direction like this. Circle for h of n in clockwise direction. This is the first part. After that, keep x of n as it is, and every time rotate rotate this outer circle in anti-clockwise direction. That means this 2 will appear over here, this 1 will appear over, this 2 will be over here, and this one will be over here. Likewise, then follow the same procedure. Take multiplication of nearby elements, calculate the answer. Then third step, again rotate it in anti-clockwise direction by 1 position. You will get next value. Again rotate it till you will get the answer of 4 points. So final answer is written as a sequence after calculating the individual values. In this case, the final answer is written like this: y of m is equals to 14, 16, 14, 16. This is known as the graphical method of circular convolution. But as I mentioned, if in the exam it is clearly mentioned ki, so obtain the circular convolution using graphical method, then and then only do follow this method. Otherwise, there is one simple method which is known as a matrix method. This is pretty simple method compared to earlier method. How to solve it using matrix method? In case of matrix method, this is consider the same given sequences. Write the answer in terms of matrix like this: y of 0, y of 1, y of 2, y of 3. Then in the graphical method, we discussed that we have rotated the sequence h of n every time by 1 position in anti-clockwise direction. So first I will be writing h of n as a column matrix. So it is 2, 1, 2, 1. This contains 4 values. Now I have to generate the matrix of size 4 by 4, 4 rows and 4 columns. So I have written h of n as a column matrix. Then transfer this 1 I mean rotate this one at the upper position, so this one will come at the top position. So if I rotate it like this, then every sample will be shifted downwards, so this 2 will come here, 1 will come here, this 2 will come here. Again rotate it by one position, so it becomes like this. Again rotate it by one position. This is the matrix of size 4 columns, 4 rows. If you again rotate it, then you will get the same column as that of initial column. This is the sequence, this is the matrix H of n which I have generated. Then write matrix X of n as a column. So it is 1, 2, 3, 4. Simple, take the matrix multiplication. The answer will be same as the previous case. This is known as the matrix method of circular convolution. This is the second method. The third method is calculation of circular convolution using DFT IDFT method. Using DFT IDFT method. I will tell you the steps. In this method, again consider the same sequences. First calculate X of k and H of k. X of k is what? DFT of X of n. How will you be calculating it? By considering that matrix of W4, then write matrix of W4 like this, then into X of n, write it as a column matrix, take the matrix multiplication, that will give you value of X of k. Similarly, calculate DFT of H of k. Step 2. Take multiplication of these two DFTs, that is X of k into H of k. And step 3, take IDFT. Again, to calculate inverse DFT, use the matrix method. That means you will be using this formula 1 by 4 Wn asterisk into whatever answer you are getting, you will be writing it as a column matrix. So this will give you the answer of circular convolution using DFT IDFT method. Now, the remaining part related to this circular convolution is, the question can be like this: why the answers of linear and circular convolutions are not same and how to obtain the same answers. In case of circular convolution, what you have learned in signals and systems, the two sequences are X of n, their circular convolution with H of n is denoted like this: X of n asterisk H of n. The result of circular convolution is denoted by Y of n. Let us make use of some notations. The number of samples contained in X of n is denoted by L. So there are 4 samples, so L is equals to 4. Number of samples contained in H of n, again it is 4, it is denoted by notation M, that is again 4. The result of linear convolution is denoted by N, that means number of samples contained in Y of n. Result of linear convolution is denoted by N, and formula to calculate N is L plus M minus 1. So in this case it becomes 4 plus 4 minus 1, that is 7. So if you perform linear convolution, then you will be getting 7 samples in the answer. Whereas if you perform circular convolution of these two sequences, just now I explained you the way how to perform circular convolution, you will be getting only 4 samples. That is, the result of circular convolution contains same number of samples as that of X of n and H of n, whereas result of linear convolution contains few more samples. It is given by L plus M minus 1. This is the reason why results of linear and circular convolution are not same. Now the question arises, how to obtain same result of linear and circular convolution, or question can be like this: calculate linear convolution using circular convolution, one and the same thing. How to do it? Using this formula, calculate value of n, just now we calculated it. Okay. Then after that, in the given sequence X of n and H of n, there are 4 samples. Make the length of X of n and H of n equals to 7. How to do it? There are 4 samples. I have to make this length equals to 7. So I will be adding 3 zeros, which is known as zero padding. Similarly, in H of n, I will be adding 3 zeros. Now the length of X of n and H of n is 7. Perform circular convolution using matrix method. Using matrix method, the result of linear and circular convolution will be same. The next part of this chapter, this unit, is fast Fourier transformation, that is abbreviated as FFT. The obvious question is, why FFT is faster? How to write the answer of this question? You should know this formula. This CM means complex multiplication, CM means complex addition. The term contains there are complex terms, so the word complex is used. if you are using DFT, complex multiplications are n square, complex additions are n square minus n. Whereas if you are using FFT, complex multiplications are n by 2 log n to the base 2, complex additions are n log n to the base 2. Keep in mind, base of log is not 10 or not e, it is log to the base 2. So if I am talking about n is equals to 4 point, then in the exam you need to consider any value of n like this, n is equals to 4. Put the values. So complex multiplications for DFT will be n square, that is 16. Complex addition will be 16 minus 4, that is 12. Similarly, do the calculation for complex multiplication and addition. For FFT, you will come to know that the required multiplications and additions are drastically reduced. This is the reason why FFT is faster. Now, there are two algorithms as far as FFT is concerned. One is known as DIT FFT. D stands for decimation, I means in time, decimation in time. And second algorithm is DIF, decimation in frequency. This is known as the flow graph to calculate the 4-point DFT. Likewise, there is a flow graph for calculation of 8-point DFT. I have just drawn one flow graph of calculation of 4-point DFT using DIT FFT algorithm. How to memorize this flow graph? Actually, you might think this is the complex diagram. It's not at all. The basic diagram is like this. Only cross connections are there. This is known as butterfly diagram. This is the hardware structure which is used to calculate the 2-point DFT. This is an example of 4-point DFT. So there are two. This is one butterfly. This is second butterfly. Butterfly is the hardware circuit used to calculate 2-point DFT. So for 4-point, you need 2 butterflies. If it is 8-point, then you need 4 butterflies, and so on. Only cross connections are there. Similarly, this is first stage. This part, I will highlight it. I will separate the two parts like this. This part is first part. It is known as first stage. Remaining is the second stage. Again, there are cross connections like this. This adder is connected to third. Second is connected to fourth. Similarly, this third is connected to first. Fourth is connected to second, and so on. What do you need to memorize? These values. In case of first stage, this is first stage. For the last line of each butterfly, -1 is there. In the second stage, for last 2 lines, the notation is -1. And don't forget to memorize this value. In case of 4-point DFT, at the output of last adder, the value is -j. How to do the calculation? Let us assume some sequence. Let us say it is 0, 1, 2, 3. And it is asked to calculate the 4-point DFT of given sequence using DIT FFT. How to do it? From the given sequence, I can simply write the values as x of 0 is equals to 0. This is the first value. X of 1 is equals to 1. Second value, x of 2 is equals to 2. Third value, x of 3 is equals to 3. Last or fourth value. Now, you need to memorize this sequence. It is x of 0, x of 2, x of 1, x of 3. In case of DIT, input is not in proper order. What is proper order? Order 0, 1, 2, 3. Input is not in proper order. It is known as bit shuffled order. So it is 0, 2, 1, 3. But output is in proper order. I will explain you one calculation. Suppose output of these adders, output of first stage, I will denote by this is say H0. This output is S1, this output is S2, this output is S3. How to calculate H0? Very simple. Look at the diagram. H0 is output of this adder. First line is X0, so I will write the equation over here. H0 is equals to X0. This is adder, so plus sign. Next is X2. This line is directly connected over here. One more calculation. Let us calculate S3, this value, because it is something different. So to calculate S3, look at the diagram. X1 is directly connected. I'm writing equation for S3. X1, this line is directly connected, plus X3 is getting multiplied with -1. So it becomes -X3. And then it is connected to the adder. After performing this, output of this adder is getting multiplied with minus j. So outside this bracket I will write minus j. That means these values will be getting multiplied with minus j. This will give me value of S3. So you will be calculating from using the diagram only. You need to calculate H0, S1, S2, S3. Then final output is x of 0, 1, 2, 3. How to calculate x of 0? Look at this connection. It is H0 plus S2. This line is S2. This line I am talking about. So that will give you value of x0. Likewise, you will be doing the calculations of all values and you will be getting answer of x of k, that is answer of DFT by using DIT FFT. This is decimation in time. For decimation in frequency, the flow graph is exactly opposite because time and frequency are reciprocals of each other. But important change related to this, one important part rather related to this. If it is asked to calculate inverse DFT, you don't have to memorize a different diagram. Suppose I have this diagram, I know this diagram, and if it is asked to calculate inverse DFT of any sequence, say given sequence is 6 minus 2 plus 2j, then minus 2 minus 2 minus 2j. How to make use of same flow graph? Very simple trick I will tell you. To calculate inverse DFT, keep the notation same, multiply every input by 1 by 4. In this case, x of 0 will be 6. X of 2 will be this value. X of 1 will be this value. This is x of 2. This is x of 3. And of course, it is DFT, so I am using capital notations like this. So the diagram remains same. Only every input is multiplied with 1 by 4. And since it is inverse DFT, I will be making use of capital notations, capital X. Rest all the things are same. Only this sign of j term should be changed. This is minus j, so make it plus j. That is the only change. Remaining every procedure is as it is. So if you follow the same diagram, you will be in a position to calculate DFT as well as inverse DFT. So these are the few important topics related to the unit DFT and FFT. Now let us discuss some different. The next topic is IR filter design. IR stands for infinite impulse response. As far as our syllabus is concerned, there are two techniques used to design IR filters. One is impulse invariance method and second is bilinear transformation, which is abbreviated as BLT. In case of impulse invariance method, you need to remember this formula. The poles of analog filter, I will explain you the steps. Equation of H of S will be given. Let us say some equation is 3s upon s square plus 5s plus 6. If it is asked to convert this into digital filter using impulse invariance method, how will you be proceeding? First calculate roots of denominator, so it is s plus 2, s plus 3. These values are known as poles of analog filter. So let us say P1 is equals to minus 2. We know how to write the poles. If it is a plus sign, sign gets changed, so it becomes minus 2. Second pole, that is second root, it is minus 3 because it is plus 3, so it is minus 3. These are known as poles of analog filter. Then using partial fraction, write it like this: a1 upon s plus 2 plus a2 upon s plus 3. Calculate a1 and a2 using partial fraction method and use this formula to transform the poles into digital poles. So in place of s, this is 1 upon s minus p1, 1 upon s minus p2 and so on. So first I will be writing it like this: 1 upon s minus 2, that is 1 upon s plus 2. This gives 1 upon 1 minus e raised to pk is the value of pole, that is minus 2, into ts. What about ts? Ts is 1 by fs. Fs is the sampling frequency which will be given in the question. If not given, consider value of ts is equals to 1 without fail. So using this formula, you can transform the poles from analog to digital. After performing partial fraction, you will be getting values of a1 and a2, and then by putting a1 and a2 and by putting values of poles, you will be getting final answer, that is h of z, which is the transfer function of digital filter. This is for the impulse invariance method. But important part related to impulse invariance method is the mapping between S plane and Z plane. This is the mapping between S plane and Z plane. How to do it? For mapping, remember simple techniques. If you are drawing any diagram using Laplace transformation. On x-axis it is written as sigma, this notation is for sigma. On y-axis it is written as j omega. Actually this is omega, I will simply read it like ohm just for the simplicity. So it is j ohm. This is the way how to draw a diagram in Laplace. Similarly, diagram in Z domain is drawn like this. On x-axis it is written as r. R is the radius of circle used to indicate ROC in Z domain, and this is j omega. Omega is angular frequency. Always for the reference in Z transformation, one unit circle is considered. Unit circle is the circle of radius 1. Now, to remember the mapping, just you need to memorize these three conditions. These are very simple conditions. How to make use of this? First condition is sigma greater than 0. For this, r is between 0 to 1. Sigma greater than 0 is which portion of this diagram? This is the origin. Sigma less than 0. So sigma less than 0 is which portion of this diagram? It is left hand side. Sigma less than 0 means negative value of sigma. Negative value is at this side. Actually it is still infinity, but as a convention we have to draw a rectangle like this. So this portion is for sigma less than 0. What is the corresponding value of r? It is between 0 to 1. Value between 0 to 1 means this is origin, this value is 1 because it is circle of radius 1. So it is the inside portion of this circle. So it indicates that left hand side of S plane gets mapped, transformed inside the unit circle. Second condition, sigma greater than 0. Sigma greater than 0 means RHS part of this diagram like this. So this is sigma greater than 0. This portion. For this, r is greater than 1. R is greater than 1 is what? Outside this unit circle. So draw one rectangle. Actually this value is still infinity. Convention is draw the rectangle and show shading outside this circle like this, which I have shown by a red pen. So it indicates that right hand side portion gets mapped, transformed outside the unit circle. And third condition is when sigma is 0. What is sigma 0? This entire j ohm axis represents sigma is 0. So for entire j ohm axis we have the value sigma equals to 0. So if sigma is 0, r is equals to 1. R is equals to 1 is which portion? This is the periphery of unit circle. So what it indicates? This entire j ohm axis maps on the periphery of unit circle. This is the diagram of mapping for impulse invariance method. The second method is bilinear transformation method. It is comparatively simple method. There is only one formula. In case of BLT, use this formula. In place of S, replace every S by 2 by Ts Z minus 1 upon Z plus 1. For BLT, do refer one important concept, that is concept of warping effect or warping concept. I have made a separate video on this, as well as I have created a separate video on the derivation of impulse variation invariance method. Do watch these two videos. So this is the way how you can convert analog filter into a digital filter. I am talking about infinite impulse response filter. The next part of this unit is drawing the diagram that is known as realization. So there are different types of realization. One is direct form 1, then direct form 2. Direct form 2 is most commonly used, then cascade form and parallel form. Consider one example. Suppose given transfer function is like this: h of z is equals to 1 plus 1 half z raised to minus 1 upon 1 minus 3 by 4 z raised to minus 1 plus 1 by 8 z raised to minus 2. I will tell you trick how to draw the direct form 2 structure without doing any calculation. Suppose this is the given equation of h of z. Then what is the maximum negative power of z? Whether it may be in numerator or denominator. It is 2. So first draw 2 delay blocks vertically like this, because maximum negative power is 2. So I have drawn 2 delay blocks. Now consider numerator term. First term is 1. There is no z term. So first at the LHS, these are the 2 delay blocks. First step is at the LHS, draw one line. It is for 1. Next is 1 half z raised to minus 1. Below this block I will be writing next value. But This is about direct form 1. I will tell you more simplified technique. If suppose you want to draw direct diagram for direct form 2 structure, then what to do? It consider numerator term, draw it at the RHS. So first line, draw it like this, write 1. I am talking about drawing directly direct form 2 structure. Whatever I explained before, it was for direct form 1 structure, but as I mentioned, direct form 2 structure is most commonly preferred. So this is first line where I have written 1. Second coefficient is 1/2. It is getting multiplied with z raised to minus 1, so write it here 1/2. There are 2 lines, make use of one adder, complete the diagram at RHS like this. Consider denominator term. For denominator term, draw the diagram at LHS. So first term is 1. So simply draw one line, write here 1. Second term is minus 3/4. Keep in mind, while drawing the diagram at left hand side, that means for denominator, change the sign of the coefficient. It is minus 3/4, so make it plus 3/4. Then next is 1/8. It is plus 1/8, make it minus 1/8. Wherever required, make use of adders like this. At the input side, write x of n. At the output side, write y of n. This is the shortcut method to draw the diagram for direct form 2 structure. So this is about the IR filter. The next topic is FIR filter, which stands for finite impulse response. The next is finite impulse response filter. This is comparatively simple compared to the designing of IR filters. There are different window techniques. You need to prepare numericals on windowing method. These are the formulae. You can take the screenshot of this formulae to do the calculations using windowing method. What are the steps if you are using windowing method? First step is the desired filter response is given by HD of omega is equals to e raised to minus j omega m minus 1 upon 2. This is the first step. M is the order of FIR filter whose value will be given in the question. You need to first calculate HD of omega. This is first step. Second step, calculate HD of n, that is inverse Fourier of this equation. Formula is 1/2 pi integration minus omega c to plus omega c. Omega c is the cutoff frequency whose value will be again given in the question. Then HD of omega, this value you will be getting it from the first step into e raised to j omega n d omega. Solve this integration, you will get a value of HD of n. Third step is h of n, that is final answer, is given as HD of omega into HD of n. It is HD of n, that is answer of second step, into window equation. Now these two steps remain same for each and every numerical. Into window equation means you need to make use of this formula. I have already created one separate video on calculation of window functions. Do watch those videos for solving numericals on the windowing equation. And the last part related to this unit, I mean most important part related to this unit, is Gibbs phenomena. Again, I have explained in the same video of window equations this concept of Gibbs phenomena. You can refer that video for preparing this Gibbs phenomena. The last unit is applications of DFT, which is comparatively pretty simple. It is the theoretical part. So this is all about the revision of some important concepts related to digital signal processing. So thank you. Thanks for watching this video.